Okay, in the last class we have been saying about the problems that has been created due to the coastal erosion along the north of Chennai harbour, and wherein the solution was, among several solutions, one of the solution was uh, fixing some structures like the pipelines. I told you also why these pipelines are supposed to be given, etc. Why these pipelines were. So I will just go back just to refresh. So this is the kind of cross section which they had adopted for coastal protection, as we have discussed in the last class. So and then these are the problems that have taken place during the due to the severe erosion. Look at this road, as I have told earlier that this road, which is considered to be a coastal highway, has been eroded completely, and because of this you have other problems. Now I will come back to that highway, how we have restored this coastal highway later, and now you see that these are the closer view at the status of this was the status sometime around late 2000, that is not 2019, early 2000 I would say. So these are all some of the pictures. Even there was a ship that got grounded here, and from this is the south and this is the north. You look at on the northern side of this ship which got grounded, even that is now seeing that is seen to be acting as a littoral barrier. See, so you see the erosion taking place. Some of the other things, see, well, houses, so many things have gone into the sea, but then the most important is a temple which is which you can see on the left hand side, and on the right hand side you can see the temple in the process of being swallowed by the coastal erosion. And now this temple no longer exists, it is a age old temple. We have lost this temple to the ocean due to erosion. So this problem was, as I said earlier, this problem was there for the last 5 decades, nearly 5 decades. There has been a number of solutions, mostly like piecemeal solutions here and there, just dumping of stones, etc. Then apart from that there were this concrete pipes installed as some kind of a long term solution, and also sea wall cross sections. All these things really failed. At the same time, you know that this is the Chennai harbour here, this is Chennai harbour, and Chennai harbour, the handling of cargo was going up, and they wanted to shift particularly the coal, etc., from here to some other location, and they wanted to develop a new harbour. So they decided to develop a new harbour at this location, and this is referred to as Ennore Satellite Port. So this is, and it is referred to as Ennore Satellite Port, and this was located around since it has to take some of the cargo from Chennai port, they decided that it has to be as close as possible. So then but it cannot be very close, so the distance between these two ports is approximately 25 to 30 kilometers, and they sited this, and when they sited this, naturally if you have two ports it has to be connected properly by road, and the only possibility of this is to connect the coastal highway. We will come back to this problem etc. later, siting of the Ennore port etc. So what happened, this problem was of coastal erosion became very important even before the port could get started. Certainly once the port becomes comes into operation, if the connectivity is not there, reaching Ennore port also will be very difficult. So in 1996 or maybe during this time, National Highways Authority of India, they referred this problem to our department. They asked us to do the survey, come out with the existing cross section, the status of the coast at that point of time, and then come out with some kind of short term solutions as well as long term solutions. So this was quite a major project and quite challenging. So the out of this stretch there are two stretches which were very severely affected. One is stretch 1 and the next is stretch 2. So this is the Chennai port and this is the Ennore port. Here we had a river which is the Kuam river, and now here we have a river connected to the Pulicat lake. I will come back to that later. Now what did we do? In the earlier one of the earlier slide I showed you the remains of the shipwreck. From that point we went on to do the survey, and we located how much kind of whether there is, see for example here there is not much of protection needed. So we identified stretch at every 25 meters interval, we surveyed the whole thing, and then you see, look at those concrete pipes all over. Here we see that the concrete pipes are in horizontal position, and then and each the chainage is also indicated. So this was the status, and we had to look into the problem of what was happening. So the sea wall that was in existence at certain stretches, we suggested as a immediate step provide an armor layer of 1.5 tons quarry stones, and as toe protection, you see that toe protection is very important, and this is the kind of temporary relief, okay, so that they can quickly get started with the rehabilitation of the seawall. At locations where the pipelines were in vertical orientation, when these pipes wherever they are vertical, they were vertical, we can easily see a lot of scour taking place. In fact, scour hole was there. So what we had suggested is to protect the pipeline, because removing the pipeline is going to be very expensive. So you leave the pipeline as it is, but then protect it, and then, but that was never done. So the some of those pipelines stood for some time and then collapsed. So you look at this some factory buildings around the same stretch. The factory buildings were also being threatened. So what we did is, the proposal after the survey, the initial proposal, this is the Chennai harbour, this is the Ennur satellite port. So this is the first stretch, this is the two stretches. So this is one stretch and this is another stretch. Groin field in the two stretches to be completed by May. We will come back to the groin field later. Monitoring of the shoreline and if possible sand bypassing from Ennur port or even Chennai port was included in the proposal, initial proposal. Then we had to take care of, we had to finalize the orientation or the length of the groins, the spacing between the groins, etc., through numerical and physical model studies. As well as field studies were involved because we need to carry out some other information about how the process is going on. And in the phase 2 we had also included some long and short groins near Ennur and Ennur as well as in fact Kuam estuary, Kuam mouth. But then I will talk about Kuam mouth later. So there are two stretches, this is the stretch 1 and this is the stretch 2. Stretch 1 was about 1.5 kilometers, wherein we had decided for this kind of a groin field. This is the final layout, but before the final layout was decided, we had gone in for several trials. So when you decide for a groin field, one basic requirement is the groin should extend at least one surf width, maybe about 50-60 meters approximately, okay. When the length of the groin is less, naturally the number of groins will increase, this is very clear, okay. So the thumb rule is 1.5 to 3 times groin length, that is the, so naturally if you have if you use the short groins, you are going to have number of groins, and if the length of the groin is small, by chance you get the filling up of the beach or the advancement of the shoreline, this will over years this will be only up to about 60 meters. But the requirement, they had a requirement that you allow as much as beach that can be formed. So we also thought of T groins, short groins, then long groins, did lot of calculations, and finally based on the requirement for the agency, we have come out with this kind of a cross section, the layout, wherein it is a transition groin, the angle this should be approximately 6 degrees. So for example, if you have, so this should be approximately 6 degrees. So I am talking about this groins, so this is the shoreline and this is the sea, and when you have this should be approximately 6 degrees for effectiveness in retaining the sand. So all these things were taken into account, and then the layout was finalized, but before that I will just explain what were other trials also during the course of my lecture. Some of the informations what we wanted what we needed was to look at how the sediment transport distribution looks like. As I said, the sediment transport is concentrated within the surf zone. So only when one way of doing it is to calculate the surf width, which is straightforward. How do you calculate the surf width? What do you need? You need only the breaker depth. Look at the lecture on wave deformation, wherein we have a number of formulas for determining the breaker height or breaker depth. Once you know H naught, T, beach slope, etc., there are a combination of formulas. I mean, each formula persists to some kind of or the type of input data you have with you. So with this it is possible for us to calculate your dB. Once you know dB, you can easily calculate the beach slope, right. So beach slope, beach slope is known. So beach slope is known. Once you know the dB from some of these formulas, then I can get the surf width. Is surf width a constant? No. How does it vary?
The sediment transport.
No, how does the surf width vary? Does it vary every day or every month, or how does it vary? Anyone?
Seasonally, because the wave heights change.
No, wave heights change mean wave heights keep on changing. No, the breaker zone, it is only a zone. Okay. Although we call it as a line, see when we talk, this is the breaker line, we refer, this is the shore, and we say that this is the breaker line. Although we use that breaker line, it is not a strictly a line that can be drawn along the shore, because every now and then the breaking point can change. But for example, even within a day the breaker line can change, but the change will not be too appreciable for maybe within a month or within a particular season. So what you do is every month you can calculate January to December, every month I can get my surf width. But as far as the design is concerned, when you want to do the design of ground field, you have to cater to the maximum sediment transport. So as far as this coast is concerned, it will be around June to August along the east coast of India, where you have maximum sediment transport. So the surf width also will be higher. So I have determined the maximum surf width. So the groin length should be definitely greater than this maximum surf width, for the simple reason it can retain all the sand. That is one way of doing it. I can simply get my maximum surf width once I know the breaking wave characteristics. Based on this, my length of the length of the groin is fixed. The other way of doing it, actually what you are supposed to do is you should go a bit deeper into the problem. Within the surf zone, how does the sand look like? How does the sand transport look like? The distribution of the sand look like? So now I have oriented my lecture in such a way that you are exposed to the field problems, and you know after the lecture you know what already why you are doing it, when I take up the problem on a problem or formulas concerning all this sediment transport distribution or Longshore sediment transport rate, etc. You understood? Instead of me starting with the problem, I have started with the problem with the actual field problems, and then I will be slowly getting into how to calculate all these things. So we did the seasonal sediment transport, which gave us some indications like see, you look at this, even up to about 200 meters we do have some amount of sand being distributed, okay. So by having the shorter groin we will be allowing certain sand to be moved. So we wanted to be kind of greedy to trap the whatever sand is moving. But now let us come back to this problem. This is the Chennai harbour, you have the Kuam mouth, Kuam river, and the wave is moving in this direction, for which the tranquility is given by this breakwater. Now I have one more river as we have seen, and now I have another breakwater here. This is Ennur, this is Chennai. How was this coast looking like? The coast was looking something like this, and the road was going something like this. You understood? So this is the road, and in fact this should go something like this. Understood? So now the suggestion was to have groin field here. When this proposal was made, the problem, arriving at the solution and proving the validity of the solution to the problem was much more easier than convincing the authorities and other experts. You understood? The simple problem is why there was objection. When the sand is moving in this direction, most of the sand is trapped here, and this is also an eroding area, and the sand is already moving from here. And when you want to have groins, where do you get the sand from? So the doubt raised, is it reasonable or not? It was quite reasonable, right? So where are you going to get? So this problem was raised all over. Although we came up with the solution in 1997, I would guess, the project had to wait for about 6-7 years to get implemented, because there was a lot of, because this is an important location and a huge amount of money is also involved. But then what was the kind of question posed by us? We said that this is stopped, okay, but still the process of the waves, oblique wave attack is going to continue here, and this is going to certainly have the longshore currents. And it is going to take the sand. If you do not have these compartments to intercept the free movement of sand, the sand certainly will go there. The sand that is likely to go there, only that sand is being trapped in between these groins, but still the sand beyond this groin area will still have its path to move into this area and create problems here. Okay. So this was a interesting problem, so which we could do that, and then we could convince the authorities, and finally we will see the results later. When we started the work, we wanted to have we tried T groins. T groins, you know that why T groins are suggested. T groins is to retain the sand when it is trying to be brought or trying to be taken away into the ocean during the downwash. So we looked at some of these configurations, short groins extending up to a maximum length of 150 meters. So you see so many groins, a number of groins jetting into the ocean also does not look nice. So then finally we did, this is a very old quite an old project wherein we did the numerical simulation of the shoreline evolution. We have now better way of projecting all these things, and then we also did the experiments in Institute for Hydraulics, Institute for Hydraulics and Hydrology. There is one institute which is about 1.5 hours drive from our institute. So they have a shallow water basin wherein we simulated all these informations into the wave basin, and we tried, an attempt was made to consider mobile bed, that is the sand was also used. Okay, although it cannot be it cannot be said that we could achieve 1:1 correspondence between the field and the lab, at least we could make some progress in that direction, and that gave us a great confidence that the system is going to work. So after convincing all the authorities, groin 6 for the stretch 1 started sometime in April 2004, I would guess. So April 2004 the construction sequence also was given. Please recollect that the sand movement is during January to May, it is moving towards north, June to September it moves towards north, and October to December it moves south. How do you know all these things about the direction as well as the quantity? That will work out a problem later. By then you would know why you are doing all these problems. Is that clear? So now when we have, so the problem was starting the project started in the month of April. When they want to do the project in the month of April, which is the groin you would suggest to be constructed first out of these 6 groins? Make a, at least whatever you have knowledge you have gained, no, you just think and tell me. Groin 6, that is because I have already indicated here, or I have already told. Now the question is, instead of constructing grind 6, what would have happened if I had constructed grind 1? The erosion will take place on the northern side. So what we had suggested is, you construct this grind first and then slowly go ahead with other grinds, but while doing it make sure that this is properly protected by seawall. There was a seawall which was in existence, but that has to be modified so as to take care of the action of waves. You understood? So the seawall was first strengthened and then this was constructed. As far as coastal engineering is concerned, the sequence of construction is extremely important. So slowly all these grinds were, now you look at the grind 6. The moment the grind construction, see construction is still in progress, you see those cranes. This is anticipated. The moment you put an obstruction, you will see the changes in the shoreline, but the shoreline response was similar to what we had predicted in the numerical model, but maybe the magnitude is not to that extent, there is variation because we are dealing with a host of parameters and a lot of assumptions involved. And if someone comes and tells that my numerical model is like this and my field is behaving like this in coastal engineering, and what is the deviation, if he says the deviation is less than 5%, it is quite hard to believe. If the deviation, if someone says that it is less than 20%, I would gladly accept. You understood? So even getting up to a deviation of 20% is not so easy, because there are so many ifs and buts. Is that clear? So now you see what has happened to all this beach formation. So any coastal engineering project of this nature, continuous monitoring is extremely important. I am sure some of you might be joining some consultancy firm or maybe some firm which is involved in construction, etc. All these things you have to have in mind. These are some of the issues being faced by some industries working in this area. So the work commenced in May 2004, and you see that only the area is being marked here, approximately 3,700 square meters. That was 13th of August 2004. 25th you had something like 7,000 square meters. By 14th September you had something like 9,000 square kilometers of beach. But see 6th January 2005, that around 9,000 square meters was reduced to by about 50%, 50% of the sand, the 50% of the beach that was found went into the ocean. Can you guess why?
Reduction of littoral.
Huh?
Change in reduction of littoral.
Change in
Reduction of littoral.
Can anyone? What happened in 2004? So last week of December 2004 we had the tsunami. and one of the devastation effect was to remove the beautifully formed beach. That is that was really disgusting, really disgusting, because we were so happy that everything, this was only in the month of a solution being worked out, that is we are getting fruitful results after 5 decades. Beach is being formed, the local people are very happy, and we as consultants we are also very happy. Suddenly you see within a matter of 6 months from its implementation, you see the sand has gone inside. So that resulted in some kind of a frustration, but then we continued the monitoring of the shoreline, and you see that whatever went inside the ocean had come back with an additional of about 1000 square kilometers. What happened? What happened? The sand which was removed from here, somewhere here, must have got deposited here. So when I draw I will draw here, all the sand might have formed here, and then slowly over the time, not this is not slowly, it is quite fast, within a few weeks the water level must have gone down, and then this bar has been removed and redeposited here. Now the beach is intact. As on today, the groin field has been quite effective, that is as on today March 2012. So only thing is care has to be taken for continuous rehabilitation of the groins, because these groins are formed only by dumping of stones. So you need to monitor and then keep on rehabilitating if it is suffering any kind of damage. Some of the monitoring information, we also just looked at the satellite imageries and try to understand using the GIS as a tool in order to quantify all these things. And there is another satellite imageries. So this is a closer view of the beach formation in between the groins taken in September 2004, and after the tsunami you can just see the 28th of December, some of the locations were still there with the sand. Tsunami did not remove the entire sand, some locations the sand was there, and the groins really sustained the tsunami, because there is not much of problems with the groins. I will come back to the effect of tsunami when I talk about tsunami interaction. So this is yet another using the IRS image. So looking at the cross section for the groins, this was the groins, this was the section. So we had I think there is a mismatch of the figures, okay. I will try to include this picture, so forget about the I think there is a mismatch of the figure, we will look into it later. So details of the stretch 2, there were 2 stretches. So this was some stretches, so I will just for the stretch 2, this was a kind of cross section we had, because for stretch 2 the cut was quite deep. So we wanted to have more of a beach formation. So that is the reason why you see that the length of the groins is quite more. So some of the other problems, see closer a river mouth, sandbar formation, etc., around the same stretch of area. See how the seawall has failed because of, see look at this, the toe erosion starts. Once the toe erosion starts, then that is a problem. Then toe erosion continues, the stability of the stones become questionable and the whole thing collapses. So we looked at the I mean the seawall cross sections. What we had adopted for some of these stretches are shown here. I will be discussing about the other for, because of the tsunami we have raised the top level of the seawall. I will discuss more in detail, but we have provided a strong toe. We have used the geosynthetic textiles, etc. I will come back to this later, but the sea, you remember groin 6 we had a cross section here, I mean the seawall, you remember. So that seawall was redesigned as shown here. We had a flat slope because normally the slope of the seawall is around 1:2. Flatter the seawall, more is advantage. If it is flatter, you can use smaller size stones. Okay, so we adopted a flatter slope, and then this is how we proposed a strengthening by about armor stones about 75% greater than around 1.5 tons. So this will be mostly about 1.5 tons, and the percentage of this one will be around 1.2 to 1 to 2 tons, and with 75% of the stones greater than 1.5 tons. This is the kind of specification we had given, they have strictly followed, and this seawall is really intact, there is absolutely no problem. So in fact we had given 2 cross sections for to be adopted at 2 different locations also. So all this informations are shown in this figure. Now comes the effect of Are there any questions so far? I would be very happy to answer if you have any questions. If you do not have any questions, I assume that everything has been clarified. Any doubts, any of you? Vinay? Okay, this is a scenario, effect of Enu satellite port. Now, what was the lesson we learnt from construction of Chennai Harbour? This was formerly called as Madras Harbour, now it is Chennai Harbour. What was that was happening? What did we understand? By construction of the Chennai Harbour there, what was the negative and positive impact?
Positive impact is that
Positive is okay, we have positive, but what we are worried is about the negative impact. Huh? Closing of river Kuam here, and then erosion here. Okay. Now you have another creek here, which is the Ennur Creek, and we have gone for another port here. The same problem is being duplicated. Okay, what are your suggestions? We want a harbour there. I want to hear from you. We want the requirement is that we need a harbour somewhere here. First of all, you understood, no, by having this Ennur satellite port, the problem which we had faced is going to repeat. Okay. Now, what is your opinion? Now that you have undergone this course, What is your opinion? Where can we cite the Ennore port? No, you need to be bold, no? You have already studied now. I am sure that I have explained clearly. What is your problem?
Ennore Creek.
Huh?
Training walls on that Ennore Creek.
That is for you are suggesting a solution for Ennore Creek. Siting of Ennore satellite harbor itself. Given, if you are given a choice, where would you locate it? First, there may be some associate problems, but first choice would be where? Before the river mouth. That is what I wanted from you people. So I would suggest to have this before the mouth, because of which the problem of erosion here could be addressed, plus you will have erosion of this mouth, because there is a thermal power plant here which is drawing continuously the sea water from this creek. Okay. So this should not be closed, and then this is actually open to a big large backwater which is called as Pulliket backwaters. You should go to Google and check all these things. Everything cannot be covered in the class. So you are right, I would locate this here, so that I get the merits of nourishing the beach in between Ennore and Chennai harbor, plus I keep the mouth open. But there are other constraints, like the amount of land available here was less. Okay. So hence it was decided to shift north of Ennore, north of the mouth, much against the wish of so many, but they had their own reasons for shifting. Okay. So one of the reason is non-availability of hinterland. You need to have a good amount of land, otherwise it would be difficult. Then look at this mouth opening. Are you happy with the mouth opening? Swapandeep, what will happen?
So it is too much extended to sea.
Huh?
So it is too much subjected to sea conditions.
What will happen if the mouth is open like this? Sand will directly go inside the ocean, inside the port. That is very clear, no? So you have sand going inside, so that is being trapped, and then under maintenance dredging, the dredging is on a continuous basis, it is going on. Now one of the reason cited by the project authority who implemented this project is that they could not have a opening on this side, because I would have, all of us would like to have a opening like this, but there are lot of large number of shoals here. Shoals means submerged rocks, and dredging through submerged rocks is going to be very difficult. That is the reason why they have a opening from this side. Again, this again is much against the wishes of so many, but the implementing authority, they have their own reasons. So with this I will complete today, and we will continue in the next class.